You're all done with robotics? Good to know. Good for you. Hi, Anirudh. How was the break, Sushank? Hey, last class I didn't see you, right, Sushank?
You did.
Mm, the last class, because I was searching for Sushank, I remember, but I don't know. I'll go check. But as far as I know, the last class, did you attend the last class before break?
Yeah, I did.
Is it? Okay. Okay. I feel like I didn't see you, but I'll check. Okay. Hi, Lopa. What are they doing in school, Lopa? Looks like schools is getting cancelled once more.
Oh yeah, we don't have school on Thursday, but
I
we're
know
learning.
Friday also they'll cancel because Dallas has already declared a holiday,
Oh
I
yeah,
think.
that's true. We're learning inverse variation. We just started it today, like just now. Like I had it last period.
Inverse variation. What is that? Wait. I'm a little off. With your class, I was going slow, I know. I started cubic functions. You started with inverse variation. Now, where is that inverse? 1 minute, Amma. Let me check. I don't remember which topic it is. Inverse I know it is in there, but I don't remember which unit it is a part of. Ah, okay. Oh my gosh, they went to rational functions. How about you? How about you guys? Yukti? Oh, Yukti, sorry. No. Not a question for you. Anirudh, what are they doing?
We started doing higher order polynomials.
We started doing higher order polynomials. That means, okay, I know what you guys are doing. Did we discuss complex solutions to polynomial equations? Did we discuss complex solutions to polynomial equations? Complex solutions mean solutions with I. Did we discuss? Did we discuss factoring of polynomials? I am a little lost. Wait. 6 and 8 we didn't do actually. Oh, six. Yeah, I know. 7 we did. So 6 and 8 is what? So you went to higher order polynomials. Okay, 6 and 8. Yeah, 6 is what you're covering, Anirudh. 8 will come next. But Lopa has gone to 9. Oh my gosh. It's really hard. Mm, okay. Anirudh, how tough it is for you to come in the Sunday class? You were coming in the Sunday class, right?
Yeah, just recently joined a class, so I think
So you can't
that,
come on this, huh?
yeah.
Okay. Okay, see. Okay, 6 and 8 we are not done. We have not done. Dividing polynomials we discussed, right, guys?
Yes.
Yeah.
Okay, cubic functions, I did give you an insight, correct?
I think I might have forgot what that was.
Which one, ma?
The wait, which one? Cubic
Cubic.
functions?
Uh,
I think I might have. I think I don't remember what the name meant, but if I see an example, I'll probably remember.
okay. 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 How about we do this? I'll continue with polynomials. But before that, let me go over what is inverse variation, direct variation. Okay. Simple ones, let me go over. And then, can you forward me your calendar, Lopa? Can you send me your calendar, Lopa?
Um, I don't think they released that, but I can see if I can
No
find.
problem. Whatever they gave, right? Whatever coming next, right? I would like to know. Can we do that?
Um, in our packet it says inverse variation, transforms of rational functions, graph national rational functions, practice graphing, multiply and divide rational expressions, add and subtract rational expressions, operations with rational expressions, and then applications of rational functions.
Okay, no problem. Yeah, I got it. I got what are they going to do. Okay.
Yeah.
Seriously detouring me.
Sorry.
But that's okay. I will see. I'll go over inverse variation now. What is inverse variation is a completely different topic. Now that see guys, I'm One second. I want to mark the attendance as well, guys, because this class I'm a little off. Algebra 2 Wednesdays. Okay, Yukti, you're here, I know. Anirudh, you're here. Shaurya, you're here. Siddhi, what are they doing in school?
We started the unit on cubic functions, and yeah,
They started the unit on cubic functions.
well, cubic functions and something else.
Siddhi, you can't join Sunday, huh?
It depends on the time because I have another thing on Sunday.
Maybe 6 to 7?
Yeah, I could be able to.
Just check out with your mom, okay? Because there I'm discussing only cubic function, meaning I'm going the way you're going. So, meaning I just wanted to be fruitful to each of you. That's why I am asking for that. Check with your mom, okay?
Okay.
Okay. Ashruta, are you here? Ashruta, are you here? That's not in here. Oh my God, people are forgetting. Mhm. Anyway, let's move on. Okay, I'll Lopa, just for you, I'm going to go over a little bit of inverse variation, give an intro to inverse variation, and then move on to the cubic functions and start and review that and continue that. You got it?
Okay.
Yeah. Now let's say, oh my God, what is that I drew? Let's say we have a graph like this. We have been doing so many graphs now. You know a line, you know a parabola, you know an inverted parabola, even you know this, right? Even they're not functions, you know about them now, parabolas, right? Horizontal parabola. You know about so many different graphs now. Remember the 12 or 13, 14 function pamphlet that I gave you? That pamphlet has this as a parent function too. What is this parent function? Let's find out. What is this parent function? X starts with a 0. It is not defined. X goes to 1. It comes from the top. X goes to 2. X keeps on increasing. Y keeps on decreasing. Do you see it? X keeps on growing. Y keeps on decreasing. When X goes to infinity, see what happens. Y goes to... Guys, please be interactive, guys.
Zero.
0. How can you find the end behavior of this? Basically, X goes to minus infinity. It just goes like this. It just goes like this. If you think about it, it cannot cross it. It cannot go on the negative. So let's see this one. When X goes to minus infinity, what happens? When X goes to plus infinity, what happens? I will say when X goes to 0, because on the negative side, it is not even defined. You see, I'm calling for a function that doesn't go like this. That I'm not looking at that function. This function clearly only exists on the positive side. So basically x tends to 0, y tends to infinity. X tends to infinity, y tends to 0. Did you guys get this end behavior of this function? Can we define the domain and range of this function? What will be the domain and range? 0 to infinity. 0 is not included. Range would be again 0 to infinity. Am I making sense? 0 is not included. We are using a parenthesis. Do you guys get it?
Yeah.
So now let's talk about a practical scenario where there is inverse variation. Inverse means opposite variation. X increases, y decreases, y decreases, x increases, something of that sort. Meaning one value Any quantity you can compare. One should increase, one should decrease. That's all. That is what is inverse variation. So, what for direct variation, remember the proportionality concepts we discussed. What was the equation there? Y equal to kx, and k was the constant of proportionality. You all remember this, right? Do you remember this, guys?
Yeah.
Yeah.
For inverse variation, we'll do it like this. There's no difference basically. We used to do it like this, okay? But here they don't teach it this way. Y is proportional to x. Y is proportional to 1 by x. When you change this proportionality symbol to an equal to symbol, you have to have a constant. Y equal to k by x, y equal to kx. You got it? Because here when x increases, y will increase. X decreases, y will decrease. This is the concept around direct variation. Directly they vary. X increases, y increases. X decreases, y decreases. That is direct variation. Inverse variation is, remember this, x is a small number. When it is in the denominator, y value is the highest. When x is a big number, 1000, y value is the smallest. The k value is going to remain constant at all times. Let it be 1, let it be 1000, let it be 10,000. It's going to be the same value. Let's say k value is 1. See what happens. When x is 0, y will be infinite. X can't be 0, okay? When x is, say, 1, when x is 1, y is 1. When x is 1000, see what happens. Y is 1 by 1000. See? When x increases, y decreases. Do you see it? That is what is inverse variation. Am I making sense? Lopa, did you get it?
Yeah, kind of.
So y equal to kx. You use direct variation, this formula. For inverse variation, we use this formula k by x. That's all. Okay. Now, an example graph that I told you, right? This is a graph which shows inverse variation. Make sense? Make sense? Now, consider a practical scenario. I have water in the tub. Okay. In volume, let's say liters. Okay. Time. Okay. 0th hour, there was 10 liters of water. Okay. But there is a leak underneath. What happens? 1 hour it became 9 liter. 2 hours it became 8 liter. 3 hours it became 7 liter. 4 hours it became 6 liter. 5 hours it became 5 liter. For 6 hours it became 4 liter. You see what has happened? Does this show inverse variation or direct variation? Inverse, because
Inverse.
one value keeps on increasing. This value keeps on decreasing. Do you see it? So basic concept is one increases, one decreases. So I will use y equal to k divide by x. One is in the numerator, on the other side, the other one is in the denominator. Can I move on? Now let's see this one. If I consider, meaning any two quantities I'll consider. Okay. Volume of a gas varies. Volume of a gas, I'll keep it as V. Inversely with pressure P. This is what is given. So you know how to relate these two quantities using the constant. You know, because they are inversely varying. So you know to write out the formula here. There are two quantities. They are inversely varying. I showed you x and y quantities inversely varying, how you need to use. Now I'm saying the volume of some gas is 8 liters at pressure equal to 3 atmospheres. Now we want to find out the pressure when volume is 6 liters. Do you think you can manage to do this? See, they have given the volume and pressure. They have said that they are inversely varying. You don't know what is the constant K. Once you find it, you can use that because K is going to remain constant come what may. You can use that K value here in this to find out P given B. When x and y was included, I said y equal to k by x. The two variables in here are v and p. They are varying inversely. right? Varying inversely means what? You can either use this formula or it can also be written as x equal to k by y. Both are going to be the same. Similarly, for these two quantities, how can you write k by p? Or you can arrive at a formula p equal to k by v. Both are one and the same. One is increasing, one is decreasing. At the end, that is what it is. Now, using what is given, you can always find out the k value. And again use the same formula to find out the new p for a v. Can we do that? Can I wait for your answers? Am I clear? Yes, no, please.
Yeah.
Okay. So inverse variation is easy provided you understand.
Wait, so we're supposed to find the K?
I think I said pressure. Not was I supposed to find K?
First you're supposed to find k, and using
Oh,
that use v, find p.
yeah. I said P.
Wait, so we're supposed to find K first, correct?
Yep. First find k.
Okay.
Without
But
k you cannot use it, right? You cannot use it in the second because you don't know
Yeah,
p.
I found K. I found K. I think I
And
should.
then use that k is constant everywhere.
Miss
okay.
I don't.
Priya, I sent a message too, but just sorry about my video. It's not working this class. I'll get it fixed later.
Miss
So
Miss Priya,
Yes.
I don't get it.
What is that you don't get it?
How to find K?
Miss Priya, is my answer correct?
Yes, everybody answered it correctly.
Yeah, I'm also confused on how to find K.
Okay. What is confusing? You guys explain what you understood from what I said. Amma, I'm here to help you. Go ahead and explain what you understood so that I'll help you. I'm saying.
I just understood that if the volume of the gas is at 8 and the pressure is 3 atmospheres, then we need to find the pressure when the volume is 6. But how do we, is there like some sort of equation we can find, or do we just have to divide the volume of gas by the pressure?
I gave you, right? When two quantities vary inversely, what is the formula that you can use? I said.
Oh, the y equals k over x.
Ah,
Okay.
so you can
But
use
okay,
that
wait. No,
formula.
but I got it till that. But I didn't understand which one's y and which one's like x.
I did say that you can switch x and y.
Oh, okay. So
See here,
it doesn't matter, right?
it does not matter at all. I did mention that. But good questions, Shaurya. Very nice. Did you understand Siddhi now?
Yeah, is it?
If you talk it out, many things you
I
will get.
just said an answer. Is that right or no?
I'll check, ma. I didn't see.
Miss
I
Priya,
really go to cubic. Yes, ma.
I came late. I don't
Oh,
get this
sorry.
either.
I am going to just continue. Okay.
Mm-hmm.
Then you have to wait. I'm going to move on. You can watch the record.
Okay.
Seriously, I'm meaning I feel so sad to tell, but I can't go back again. Go ahead. Siddhi, that is right, Siddhi. Use that K and use the same equation to find out P. Use the value of K. Aryan, what is going on with you?
Auntie, I'm honestly like a little confused because
Where are you confused? You can also talk it out, Aryan. I'm here to tell you.
so of something is at 8L, then that means 8L is equal to K over 3 atmospheres, right?
Correct. Why don't you use that? Correct. So
So
use
then,
that K value in the next again the same equation to find out P given V.
I don't understand what to do next after I find K.
Find out K, use the same equation, put the value of K and V, find out P.
Yeah, but like, how can I find P if I don't know V?
You're given V, right? Siddhi, please read the question, Siddhi. What is the question here?
One volt.
Did you
Is
get
my answer right?
Aryan? That's correct. Sushank, that's right. Aryan, what is that K? Kelvin, what is that K? Oh. P, what units, Aryan? There are no units in your answer.
Oh, sorry. My bad.
Okay, so I am thinking that you should be able to distinguish direct and indirect variation right now. That is my thought about what has happened. So, indirect variation, when there are two quantities y and x, you will directly write them like this, both in the numerator of either sides. When it is inverse variation, it will go like this. Am I making things clear? Whichever quantity is inversely varying, then one should be in the numerator, one should be. Suppose I say there are three quantities. Y varies inversely with x and z means what? Same logic. Y will be equal to k by xz. X and z are inversely varying with y. You got it? If they are directly varying, suppose if this is direct variation, y will be equal to k times xyz. Am I making sense, Yukti?
Yeah.
Am I? Okay. Okay. So let me ask you this. Shruti, did you get it, ma?
Yes.
Okay. Now,
Priya auntie?
yes, I know that you just logged in. You're just going to follow. I'm not going to go back and reteach now. From where we are, you're going to go ahead and you're going to watch the recording. Because you know what? Honestly, Advik, I'm so sorry to tell you that, but this class, right, we are already lagging. So I really want to keep going and all of you
Okay.
should log in on time. There's no
It's
other
alright.
go. Yeah, I understand. But I'll help you wherever you want to catch up, but not now. We'll go on
Alright,
as
can you tell me what the topic is?
this is inverse variations. I'm going to give an intro to inverse variations and then I'm going to move on to cubic functions. Okay, this is
Um,
just an intro to inverse variation and direct variation. Okay, now given this table, right, cost varies. Uh, One
It
second.
varies by the tickets.
Yeah, varies with the ticket. Science be like. Yeah, please. Thank you. I don't want to give. Okay, so cost varies directly with tickets because that you all know, right? This is a practical scenario. Varies with the number of tickets. It's a practical scenario. You can form your own equations now. Okay, what is the cost of 12 tickets? That's all. Is this direct variation or inverse variation? Number of
Direct.
tickets increases. What happens to cost?
It increases with it, so it'd
Increases.
be direct.
Yeah, so it's going to be direct variation. C and T are going to vary directly. So you have so many pairs, you can find out the constant. Once you find out the constant, you can apply for the unknown. Shruti, am I making sense? Looks like you're lost.
Oh, no. I'm focusing.
Okay.
It makes sense.
No,
Yeah, it
maybe
makes
said
sense.
I'm not clear as well. That's what I asked. Okay. Go ahead. Amma, please don't
Wait,
think
when you wrote
hard on
ticket
me.
T,
Yeah,
is
go ahead.
T just the variable?
Yeah, T is just the
Oh,
variable. X
okay.
and Y, just like X and Y, T and C are variables here. Lopa, did you get it?
Yeah, I do.
So this is completely a different topic so that Advik and Aryan can follow too. So that's why I thought, oh, I'll go from here. Now I'm going to go back to cubic functions and but I want to do one or two more problems. Then only I can go. So 461 to 466 you'll do. But without fail, do this, guys. 461 to 467. 461 to 467.
Miss Priya,
Mm-hmm.
do you just want us to find what it would be if it was 12, the ticket?
Yes, ma'am.
Oh, okay.
It's an easy one, right? But see, the thing is, when you look at the table itself, you can predict. There's nothing hard about this. But you
But
know,
is my answer correct?
yes, see, not a big question at all. Everybody knows. See, 12 by 3, 27 by 28 by 7. It gets you the answer. But at the end, sophisticated definitions we want to introduce in algebra too. This is directly varying. What is the difference between directly varying and inversely varying? So when they bring it in, it becomes a little it seems a
So
little.
like wait, so like for direct, they both x and y like increase or decrease?
Yeah, y equal to kx. See, yes. Tickets increase, cost is going to increase, right? Or I can put it out as t equal to kc. The other way as well is okay. Both are one and the same. Here, 3 and 12. 3, 12, k. K is equal to what? 4. If you have it as 4, then use the same formula. Put 12. What is 12? 12, 4, c equal to 48. That's all. So you have to find out k. K will be constant across. That's all. Am I making sense? I'm going to move on. Now I'll expect values, the answers from everybody. Okay. Y varies inversely. Varies inversely as x. Y equal to 10, then x equal to 4. This is a very skill-based problem. What is x when y is 8? Let me know if I'm not clear, guys. Is it like that, Lopa? No, it's okay.
I think I messed up.
Hey,
I'll
did you
redo
do
it.
that on the board, Lopa?
I'm not really sure how I solved it though. Can you explain it?
No
'Cause
problem. I want you to solve on the board incorrectly. Can you do that? It's okay. No,
I don't
everybody got 3.2. Why?
I just thought it was like a direct correlation because I did 10 over 4 and then I thought it was like the last problem, so I think that's where I made a mistake. But I'm not too sure because I just learned this.
Very correct. Okay, but I gave you inversely, right? Can you redo?
Don't you pair the 10 with the 8, Miss Priya?
I thought it was like y over x. I'm not sure.
Did I give you that formula? What formula did I give you for inverse variation? What
Y-
formula did I?
Y equals k divided by x.
Yeah. So can you use that, Lopa?
Yeah, can I resolve it?
Yeah, I'll wait, Amma.
Miss Priya?
Yeah. 1 minute, Susha. Siddhi, can I get an answer from you?
I sense it.
Because inversely varying means one is going to increase, one is going to decrease. No. Where did I get this question from? 1 minute, wait. Maybe I'm looking at the wrong place. No? 1 minute, Amma. Okay, that's correct. Shri correct. Mano correct. Correct, you got it right.
Actually, I don't know how to solve it.
Is mine correct?
Saurya correct. Illama. Sushank. Yes, yours is right. Advik, can you please explain how you did? I'll help you, Advik.
Oh wait, I just divided. Okay, so this is what I did. So I divided, since I have to find x, I divided I made what do you call it? Y into 1. So I divided 10 by 8, which no
Why
wait.
would you divide 10
No,
by
no,
8?
no, no, wait. I just solved it. Wait. Let me. So wait, so what 10
Okay,
is
to resolve.
no wait. I solved it. I don't know why I just didn't. Okay, wait. Let me think again. I don't know. Wait, I just solved it right now. Wait. I got 3.2 because I made it into 1, the y variable, and then I multiplied then I like multiplied it into like I made y 1 and then I multiplied it into 8, which made x that 3.2.
Aryan, how did you get the answer? Siddhi, I want you to try, Siddhi. What is confusing? I've given you the formula. You're going to use this.
Auntie,
Plugging in values here, right? 1 minute, Ma, Aryan.
Yeah.
Siddhi, you're going to just plug in values here, find k. And then you're going to use that k again in the same formula. You have y and k, you're going to find x. Can you do that for me, Siddhi? Ashrita, you as well. Yes, Aryan. Sorry, Aryan. Tell me.
That's okay, Auntie. But I realized that I messed up on my answer.
No problem. Can you redo?
Yeah, I was just about to redo it. But
Redo
I
and
also wanted to say I'm a little confused.
Amma.
So I know that y equals to k over x. And x is a value that we have to find currently. So k over y could equal x as well. But I'm a little
No, they have given this. Use this to find out k. K is always a constant. So
Wait.
find out k from the given y and x value. And then use that k here.
Okay.
Wait, Auntie?
Yes.
I realized how I solved it. So like
K is 40. K is what is the value of k? Siddhi, correct. Please proceed.
wait, Auntie?
Advik, I'm hearing. Go ahead.
So I just divided 4 by 10 since I wanted to make y 1, and then I multiplied that by 8.
Why would you want to make y 1? Y is 10. It's clearly given you're
I
going to
meant
increase
I
the
meant
value.
no wait, because I'm trying I tried to make, because y1 equals x 0.4, because when you divide x over y, that's how I solved it. I don't know.
Why are you dividing x over y? Where is your formula?
Oh, I didn't use a formula.
It doesn't make any sense to do that way, right? I am saying for inverse variation, either y equal to kx. This is for direct variation. For inverse variation, you're going to use this.
Oh, okay.
Why? What is the advantage? Here, when y increases, x will increase because it is a multiplication relation you're developing, meaning you're multiplying with a factor the x value to get y. So when x increases, y will also increase. You're having a multiplication factor here. But then here, if x increases in the denominator, y's value will reduce overall because x and y, x in the denominator on one side, y in the numerator on one side. So it's a basic equation which tells direct and inverse variation differences. Whatever they give, you are going to use that formula in your problem. Given x and y, you are going to find out k. Use k to find out the other values.
Miss
Am I
Priya,
making sense? Yes,
is my
Ashruta.
answer correct?
Siddhi, correct.
Okay.
Oh yeah, I think I get it. Kind of.
Okay. Let's say, okay. I'm renting a bus. Maybe this is the last problem in this. Okay, I'm renting a bus. C is the dollar. Each person pays to cover the cost of bus. Okay, this varies inversely with P, the number of people. You know why, right? Number of people increases, the cost per person is going to come down. Okay, now cost is $30 if 50 people go. What is the cost per person if 40 people go? That is a question. Quick, ma.
Priya, I don't really get this. I'm confused. How do you?
Exactly the same. There is no difference.
I don't get it.
Okay,
Like,
we are going to skip now in this case. Okay, from the next topic, we'll see whether you understand. I want you to join on time, otherwise, it's very hard. Manav, the cost per person, right, Manav? Do a sanity check on your answer, Manav.
Oh.
Yeah, when you do a sanity check, what should happen? They're varying inversely, they've given. So one value has reduced. What would happen? Would it increase from 30 to 375, you think?
No.
Yeah, that's what I
But
feel.
I got my but I saw my K value was like 1500.
That is right. But after that, something went wrong. See what is wrong.
Oh, I think I'm yeah, I'll check that.
Yukti, that's right, ma. Yukti, that's right. Oh, Manav, I know what you missed. Decimal point.
Oh, sorry.
No problem. Check. Anirudh, that's
Yeah, now I think now I got it.
Yeah. Anirudh, that's incorrect. Anirudh, would you mind explaining to me how you got it?
I don't know what I did wrong. I
It's
think I
okay,
couldn't.
right? Meaning I am not getting how you solved it. It is my inability to understand. I'm asking you to explain. Feel
I
free
thought.
to explain even if it is wrong. Just because of my inability to understand how you did it wrongly, I'm asking you to explain. Don't think just because, oh, I should not explain, I'm wrong. Don't think like that. Tell me. So,
Kind of set it up like a ratio,
mm,
and then, like simplified it down, and then
no,
simplified the.
please, no. I
Yeah, I
understand.
know.
I really very much, I'm proud of you that you remember proportionality and you're trying to solve using proportionality, which is great. Okay, but okay, let's see. How did you solve? Go ahead. Anirudh, go ahead.
Could I write on the screen?
Yes.
Is my answer correct?
The problem is you're trying direct variation. Proportionality is related to direct variation. This is indirect variation. Wait. Yes. 1 minute. Anirudh. This is the constant K in direct variation. You get it? Y
Yeah.
1 by X equal to K. This is direct variation. But I have clearly given the quantities are inversely varying. So the formula that you're applying is itself incorrect.
Oh,
In
okay.
this case, K equal to Yx. The two quantities should be multiplied. If you want to find the constant of proportionality, basically multiply it 1500. So that is your K value. That should be equal to the product of the two quantities.
Oh,
You get it?
yeah.
So 40 times what is 1500? 37.5 is the answer.
Okay.
Yes, go ahead. The thing is, the proportions that you learned in 7th grade, I'm very proud that you're all using it. That, see, proportionality is a graph like this. X increases, Y increases. It shows direct variation. But I have shown you a graph where inverse variation is this. For this graph or this. For inverse variation, this is not applicable. Here, you see Y by X equal to K. Or Y equal to Kx. You can use either this or this. Whereas
For
here,
the inverse, wait, for the inverse, could you do yx equal k?
yes, all are one and the same, right?
Yeah.
The product of the two quantities is the constant in inverse variation. The quotient of the quantities is a constant in direct variation. You got it? See, I am showing you multiple ways, multiple perceptions of seeing the same concept.
I had a question.
Yeah, go ahead.
What would happen if k was negative in the inverse function? Then would it still be considered an inverse function or something else?
Okay. K will not be negative. Okay, I should have specified, I feel. But if K is negative, right, Amma, it will become the opposite, right?
Opposite meaning?
Opposite meaning, okay, K is always a positive constant. I should have mentioned it, I honestly feel. In
Oh,
constant
okay.
of proportional, I don't want meaning. In constant of proportionality, have you seen a scenario where K is negative? No, right?
Okay.
I am meaning, but a good question. If it is negative, it won't work, Amma. K is always positive, but I want to defend myself better. It will become the opposite though.
But if k was negative in like the y is equal to kx, then would that become an inverse function? Just if it was.
Okay. See, in proportionality, K can be a non-zero number only. Okay, they have not defined that it has to be that it has to be positive or negative. However, we only consider relationship with a positive value of K. Am I making sense?
Yeah.
Meaning the K value as such, for skill purposes, we can say it can be positive or negative. But we don't consider scenarios where K is negative. You see.
Yeah.
Yeah. See, that becomes the opposite, right? That is what I feel. Meaning, if K is negative, right? But I like the question. If this was direct variation, right? K is negative, now it becomes like this, right? Meaning, it will invert the graph. It will, it will oppose the scenario that we are talking about, right? Because negative na greater the negative, the smaller the quantity. Correct?
Yeah.
So let's not consider scenarios where K value is negative in any, irrespective of inverse variation or direct variation. We will not consider scenarios that involve negative values of K. Can I make that
Okay.
assumption?
Yeah.
But a good question. Yes. Can I move on? Okay. You guys remember what are cubic functions? So the homework would be page number 461 to 467. Page number 461 to 467 in the book as a part of this. As a part of this inverse direct variation. Now, I need to go back to cubic functions and make sure. I know that we covered cubic functions in one day we covered. Okay, one class we entirely covered cubic functions. We graphed cubic functions, meaning y equal to x cube. We graphed it. Do you all remember? Yes, please go and come back. Do you all remember how to graph this function? Any
Yeah.
function. Y equal to x, if I ask you to graph, right? What would you do? Draw a table. Consider two negative values, 1, 0, two positive values. Plug it into this equation and see what is y. These become your xy quantities in a graph, right? Minus 1, minus 1. Minus 2, minus 2. 0, 0. This is how you graph functions, right? Correct? This is the way you would graph functions. So if I give you this, what would happen? Similarly, I'll start drawing a table. Advik, from here you should follow Advik. Advik.
Yeah, right now, currently right now I understand
Yeah.
about the graphing thing.
Yeah. So that I expect you to understand.
Yeah.
Minus 2, then plug it in here. What is the value of y, Ashruta?
Value of y would be 8.
Minus 1, 1. 8 or minus 8, ma?
But isn't it negative 2 to the power of 3?
Yeah. So what is the answer?
Wouldn't it be 8? Because even if the number's a negative, won't it? Or is it? Oh, okay.
Minus 8, right?
Yeah.
So minus 2 is minus 8. Minus 1 is a minus 1. Indeed, this is a parent graph. A parent graph means a big thing under which we are going to study a lot of problems. This is one of the parent graphs out of that 13 functions that I gave on day 1 of algebra 2, right? This is one of the functions, cubic. These are called cubic functions because the power of x is 3. When the power of x is 2, maximum power of x is 2 in an equation given, right? That is a quadratic function. Y equal to x. This is a linear function. This is a cubic function. This is a quadratic function. Now, how do you plot this cubic function? 0, 0, 1, 1, 8, 8. See? This is how we graph it, right? So a cubic graph will be like a chair. This we learned it already. The thing about this is, remember every graph has something called reference points. Reference points means in the parent graph, this is a parent graph. Parent graph means we will shift to the left, up, shift down, shift right, shift left, and then stretch it vertically, stretch it horizontally. All things we'll do with this graph. That is called transformations, right? So, but this main graph, we will have reference point. These three are the reference point for a cubic function. It is 0, 0, 1, 1, minus 1, minus 1. These three are called the reference points. Whenever we do transformation, we need to plot these three. Plot these three in the sense, these three x values, you have to find the y value and plot it. Let's consider this. How about this? I know Advik, Aryan and Advik, I don't know how much you can cope
Yeah.
with. We see how we are going to go. How about this? Who is going to explain? Who, meaning many of you know this already. What is the transformation on this graph? The parent graph is this. The parent graph for this is this. So what transformation has it undergone? Can we do one by one? Who can shout out?
I think I can do like one part of it. I think.
Good job. It comes from algebra 1 as well. Go ahead.
Yeah. It would be a dilation, an inverse dilation. I'm
Okay,
trying to
I'll let
understand it
somebody who
because
is
it's
in
Oh wait,
algebra.
I know one of it.
What is it?
The x minus 3, it would be 3 to the right.
Wow, good job. So, but that will be the last. Translation is always the last. What is this minus and what is this half?
Reflection over the x-axis and a vertical compression of 1/2.
Reflection over x-axis is the negative sign. Okay, and then vertical compression. Good. This half is for the entire y, right? It's not applied to the x. It's not inside the parenthesis. If the negative is inside the parenthesis, it's a reflection on the y-axis. And similarly, if this number that's multiplied is inside the parenthesis, it is a compression or a stretch on the x-axis. So it is outside. So outside also the number is less than 1. So it's a vertical compression of half. Am I making sense? This is quite important, guys. Okay. So how to graph it? You all remember how to graph it? Do you all remember how to graph it? Okay, I'm going to do it. Y equal to minus half x minus 3, the whole square I gave you, right? So verbal description we had. What was that? Reflection on x-axis, then vertical compression by half, and right by 3. We had this verbal description. Now tell me, reflection on x-axis means, suppose if I reflect the point on the x-axis, what coordinate is going to get affected? X will get, y will get affected. Vertical compression half. Vertical compression means vertically compression means it's applied to y or x?
Y.
Y. Right by 3 means which coordinate will get affected?
X.
X. Now, let's write out the parent function, transform function. I want you to write out the table for any transformation. X, y equal to x cube. This is the parent function you all know. I said we are going to plot only the reference points. -1, -1, 0, 0, 1, 1. You have to plot at least 5 points. Okay, I'm doing only 3. For the transform function, here is where the confusion starts. X only this, right? Right by 3 means I am moving the x coordinate to the right by 3. So x plus 3. Y, what happens? Y value, I am multiplying by half and I am negating it. I am multiplying by half and negating it. Am I clear? So now it's all plugging in only. X is here for you. X plus 3 is what? 2, 3, 4. Am I making sense? Then y what happens? Minus half y. Half, 0, minus half. Make sense? Now plot these points. My parent graph is this. The new graph is what? 2 half, 2 half. Oh my gosh. 2 half and then 3 is a 0. 2 half, 3 is a 0. Let me see, guys. 2 is a half, 3 is a 0, 4 is a minus half. Okay, makes sense. But we need more points, guys, honestly. Meaning, yeah, I think the graph is correct though, but we would need more. I think the graph will be like this. But we might want, see, you have to elaborate it to -3 and then a +3. Then only you'll get a good graph. Or even you should have let's say -7 +7. You should have it. Then only you can graph it properly. So,
I have a question.
go ahead.
Say for the right table, like you know, it's 2, 3, 4. So if say we have like 1, 2, 3, 4, 5 on 1 and 5, like I'm kind of confused because I don't know which side is the x and which side is the y. So I don't know because like both of them are equations. So like
Sushank, sorry, Sushank, I didn't get your question. Would you mind elaborating again?
so like x plus 3 and then there's negative 1/2 y. So how do we calculate, like say we have a different value, like maybe let's say we have 5, how do we calculate the 1/2 y or for
Sure.
5 or like something like that?
Sure. You want a 5 here, huh? Okay, let's erase this off. You want more points here? I'll do. You want a 5 here?
No, not on that one, the one on the right.
You want a 5 here?
Yeah.
Okay, for that
Like,
matter, then what it should have been, 5 minus 3 is a 2. Suppose we have 2 and 8. How does it change? I'll tell you. Here 2 plus 3 is a 5. 2 plus 3 is a 5. 8 substituted here, it will be a -4. Am I making sense? Am I making sense?
oh, we take it from the parent function?
Yeah, from the parent function only you can draw the
Oh,
transform function. Parent function x, parent functions y, you're going to plug in here. Am I making sense?
I understood it now.
No, I'm going to give you problems because I want you to be able to graph transformed functions very nicely. How about if I give you this? Who is going to answer what are the transformations? How about 2 times x plus 4, the whole cube?
Vertical stretch by 2, left 4.
Careful, careful, careful.
Wait, no, horizontal compression by 1/2.
Horizontal compression, which inside the parenthesis means immediately find the reciprocal.
So
Now
horizontal compression by
that
1/2.
number is less than 1. So it's Ashrita, are you following Ashrita?
Isn't it by 4?
Yes, I am.
Miss Priya, isn't it the compression by 4?
Oh my goodness, did you forget? What is this, Manav? X plus 4 is movement to the right and left, right?
This is left 4.
It is left 4.
Yeah, but like for the compression, I don't know if it was 4 because it was like 1 over b. Oh, never mind. Like,
And then it's up 1.
And then what is this?
Up 1.
Up 1. So up 1 is y-axis, left 4 is x-axis. Horizontal compression means it's applied to x. So my xy of the parent is in here. But the transformed function x and y, how is it going to change? You're going to apply the half multiplication to x and left by 4. This is a little tricky. Please don't apply translation first. Translation is the last to be applied. So half x minus to the left, right? Half x minus 4. Up 1 is y plus 1. Am I making sense? Shaurya, are you with me?
Wait, Auntie.
Yeah.
Yes,
So
ma'am.
if
Aryan.
it's so if it's inside the parentheses, it's horizontal, and
Correct, because the two don't take it as 2. If it is inside and is for x, now you have to find the reciprocal of whatever number is in there. If that reciprocal is less than 1 means it's compression, because see, you multiply something by half, you're multiplying x coordinate by half means you're compressing it. So it's a horizontal compression by half.
yeah,
You got it?
I got it.
So no, I'm just asking. I'm not graphing yet. I'm going to give you more problems, but the more we understand, the better it is for you. So I'm going to give you more questions
Yeah, I
to
was just trying to
transform.
understand because I haven't been for a long time. So
Yeah. So how about this? I want to give you more graphing problems, and when you're given equations, you should know as well. Let's see. How about this? How about this, guys? Minus 1 by Lopa. Can you tell me what are the transformations? I didn't mean to pick or bug you, but try Lopa, otherwise I'll pass it on.
A vertical reflection.
Vertical ma, why vertical ma?
Sorry, a reflection across
Reflection on?
the x-axis.
Wait. No confusion, please.
The x-axis.
Which value is negated? X value is negated. So it is a reflection on what axis? If the x value is negated, it is a reflection on what axis?
The y-axis.
Reflection on y-axis. So it is applied to x. Then
Vertical compression by 1/4.
why vertical compression? It is clearly inside the you told about.
Oh, I'm sorry, I didn't see the parenthesis on the other side. Horizontal stretch.
Good. Horizontal stretch by
4.
or apply to the x-axis because it's horizontal. What is this?
Right 1.
Right one. Then
Up 2. Sorry, I didn't see the other
no problem
parenthesis.
at all, ma. As long as you get it right, I'm happy. So 3 transformations are being applied to x. Anirudh, are you getting nicely?
Yeah, I understand it.
Wait,
Okay.
the 1/4 is a what do you call it? Horizontal stretch, right?
Correct.
Okay.
Because it is inside the parenthesis, and always if it is on x, right, the compression or stretch, the number, right, should be reciprocal. We should find the reciprocal of it. That is 4. This 4 number, if you multiply with x, now it is going to increase. So it is a stretch. You
Okay.
got it?
Yeah.
So now I'm going to give you a problem. So why don't we graph this? You graph this and show me on the video. I have written everything for you. So you're going to draw the table for parent and the transform graph. In the transform graph, your x value will be, first x value will be minus x. After that, minus 4x because it's multiplied by 4. And then minus 4x plus 1. Y will be y plus 2.
Wait, Auntie, can you repeat that again? I'm a bit confused.
X value, how does it change in the transformed graph?
It becomes negative.
It becomes negative. It's multiplied by 4 and it is added 1. So minus 4x plus 1. Advik, am I with you?
Oh yeah. Oh, okay, I get it now.
Yeah.
Since of like that, based on like what you did to the equation, how was like, oh yeah, oh yeah.
Miss Priya.
Yes, ma.
So just to make sure, you would put in like any value of x and y, and then you would add on these rules to them, right?
Yeah, correct, ma.
So just any value is fine for the initial one?
For the parent one? For the
Oh,
parent.
yeah. Sorry, I forgot that we had to do parent.
Yeah, parent function, any value is okay. From there only you can get. For that text only you have to use to make this transformation. You get it?
Yeah.
Meaning x y parent. Okay. Now you can have some nice values you should have. The entire graph should be drawn, right? So I would always take a minus 10, minus 5. Meaning don't always take. Go for values which makes it easier for you to work out the y. You get it? So y will be 1000. This I don't want. Minus 1000 I don't want. Minus 125, minus 8, 0. This will be 8, 1. Now transformed, I will write what applies here. Minus 4x plus 1. Y will be 2y. If you didn't understand this, it's high time you ask. We have done absolute value functions for this. We have already done quadratic functions with transformations. We have done so many.
Wouldn't it be 1/4?
One,
Because
it won't
it's
be 1/4. It is applied on the x-axis, right? I said you have to find the reciprocal.
Oh, okay.
That is often a forgotten factor across several
Oh,
algebra.
but for the compression you do half or fourth.
Yes. Then they would have given you as 4 in the equation.
Auntie, do we have to show you like on video? Because I don't currently have
Yes,
paper
yes,
on
yes.
me.
I want to see on video. Yes.
Okay. Can I get paper and come back?
Sure.
Auntie,
Yes, ma'am.
would the point of inflection be on 1 comma 2?
With the go ahead, ma.
Would the point of inflection be on 1 comma 2?
For that one, no. Yeah, correct, ma.
Okay.
So, okay. How did you define the point of inflection at school?
Oh, we take the opposite of the one that's in the parentheses, like that's next to x, and take the one that's outside the parentheses.
Yeah, that's how I did it too.
No, which one did you take?
The
No,
-1, I flipped the sign and took it, so it was 1, and then took the number outside of the parentheses.
that is h comma k. Okay, I want to bring that up. See, no. I wanted to understand what is meant by, meaning, did you know what is the point of inflection?
Yeah.
You spoke about it, right? What
Can
does
I
it
show you my graph?
means what? Yes, you can. Anirudh, do you know?
Where the
Illemma.
graph
Yes, Yukti,
switch.
that's very nice graph, Yukti. Point of inflection you mentioned, right? What does it mean? Do you know? Meaning, it's okay if you don't know. I'm just asking. Anirudh, you brought up a very
It's
good
the
point.
point? Is it the point that where the graph like flips?
Flips from what to what?
Um, I don't know, like the flipping thing. I just know that's the point
Just
where
the
the
vertex,
graph
is it just the
flips.
vertex?
Yeah, correct. It is the vertex. It is the point of it. Yes, Yukti, the Shruti, correct, ma.
Well, that was me. That was Shri.
No, Shri, I did not see your video.
Is mine correct?
No, my video isn't working. I'm just talking from audio.
Yeah, then how can I see the video and say? No. Oh, yeah. See, it is the. Oh, sorry, Shri. Got it. So you're talking about the vertex. It is correct. But the point of inflection, now, have they taught you about concavity? No, right? No, right, Anirudh?
No, I don't think so.
Notice concavity up and down.
Yeah, it changes from concave up to concave down. That is why I
Oh,
wanted you
yeah,
mentioned
they did talk
inflection.
about.
You did talk about it. Okay. See, whenever seventh grade kids, please wait. Okay. I really want to finish this one for them. Okay. Now the graph is going to be something like this, guys. Did you guys get it? If you didn't get it, you have to ask. One thing is, a couple of things I want to discuss in cubic functions. You all know this
Wait, can
is
you verify my graph? I'm still not sure if it's correct.
okay. Sure. Sure. It is a book problem only. Show ma. Show Sushank.
I am.
Oh, sorry. Wait. Everybody joined in. Yes, that seems okay. Not exact, but seems okay.
Okay.
Yes. So now here, I really wanted you guys to understand this. If this is the origin, meaning origin is your h comma k. You see it? The center point, 0 comma 0 reference point. That is one of the reference point, right? That's called h comma k. If that is 0 comma 0, this value, this equation holds good. But if it is not, right, y minus k equal to, I'm sorry, x minus h the whole square, x minus h the whole square plus k. This is the equation. You see, this equation, because of that x is moved by h, y is moved by k. So, the equation for the cubic transform, this is the parent cubic graph equation. This is the transformed cubic equation. Okay, here you see, here if we add vertical and horizontal compression and stretch, right, you know how it works. I will add a here, and then if I want to include the horizontal stretch or compression, right, I'm
You'd
going to
add x over b.
correct. So a for horizontal compression or stretch, 1 by b. For vertical, this is for horizontal stretch or compression. This is for vertical stretch or compression. Vertical compression or stretch, horizontal compression or stretch. This is h comma k reference point. Please note down these equation formats at least. So next week, if I give you points, you should come up with, I'll give you, hey, these are the points in a cubic graph. Go ahead and write out the equation. That you should be able to do it next week, and we move on to polynomials.
See, is this just a way to like describe the situation? Like say the 1 over b in the parentheses would be a horizontal compression.
One, 1 over b. If you have 1 over b means b is the horizontal stretch or compression. I told you you have to find the reciprocal if it is inside. B is the
Oh,
horizontal stretch or compression. A is the vertical stretch or compression. Okay, if A
yeah.
has a negative sign, then there is a reflection on the x-axis. B has a negative sign, there is a reflection on the y-axis. Make sense?
Yeah, auntie, I got it. Also, will you be posting the homework?
Yes,
Like, do you
yes,
know when?
460. Yeah. See, 461 to 67. Oh, you need to have the books. I've sent the welcome emails all. But then you need to have the book as well.
Wait, there's new books or is it the same
No,
book?
no. It's the same book. See, for those of you who have been doing it, please don't worry. These kids came in between and they're trying to gel in. We'll see. Okay. So for those of them who are new only, I'm telling. Okay. Page number. I really want you guys to work on cubic functions and transformations. So for cubic functions, I want this was already given. I don't know if you have done 315 to 329. 315 to 329 in the book.
So that and 461 to 7?
Yeah, 461 to 467. I'll post it. Okay, but next week, please remind me, Manav, we have to work on, given the points, you have to write the equation for cubic functions. And then we move to polynomial graphing.
Okay.
Kavin, no problem, Kavin. Manav, I saw all your points. Seems okay.
Okay.
Guys, we can see all next week.
Is it okay if I turn in the homework on Wednesday?
Yes.
Okay.
Before the class, if you submit it, I'm fine, Manav.
Okay.
And Manav, thank you for letting me know. Last time, before the break, you logged off the class soon. And I was indeed very doubtful. Oh, why Manav logged off quickly? But I saw your post in the stream. Thank you for that.
Okay.
Okay, bye, guys.
Bye.